This Zoom session is being brought to you by the Fractal Fire. All right. Today, this is the end of a chapter with an odd number of sections. So uh, it's going to be 3 today rather than 2. So it'll be 2.5, 2.6, and 2.7. 2.5 shifting function graphs, 2.6 combining functions, and 2.7 inverse functions. Okay, you can shift the graph of a function by changing its formula a little bit. If you have a graph of a function y equals f of x, then y equals f of x minus h, that quantity k, it has the same graph except shifted left, right, up, or down. So for example, here's absolute value of x. It's a V-shaped graph. You add k outside the absolute value of x, that shifts the graph up or down. So here's the graph of y equals absolute value of x. Here's absolute value of x plus 1's graph. Here's absolute value of x plus 2. Here's absolute value of x minus 1. Here's absolute value of x minus 2. So f of x plus k, the k outside the function, shifts the graph up k units if k is positive, down if absolute value of k if k is negative. Now here we have y equals absolute value of x minus h, the minus h inside the absolute value sign. So okay, that shifts the graph left to right. Here's a graph of y equals absolute value of x. Here's a y of y equals absolute value of x minus 1. This minus 1 delays it by 1 unit, and so it shifts it to the right. That's a funny thing. Plus 1 outside the absolute value moves it up. Minus 1 inside moves it to the right. So there's a sort of a reversal effect. Absolute value of x minus 2 has a graph like this, shifted to the right too. Absolute value of x plus 1 is shifted, advanced 1 unit, so it's shifted 1 unit to the left. Here's y equals absolute value of x plus 2, shifted to the left. You can think of it as y minus the absolute of x minus negative 2. So it's right negative 2, in other words, left 2. So y equals f of the quantity x minus h shifts the graphs right h units if h is positive, left if h is negative. And if you do both of these, you have a double shift. F of the quantity x minus h, all that plus k, shifts the graphs h units right if h is positive, and k units up if k is positive. So if this is the graph of y equals f of x, then y equals f of x minus h, that plus k is shifted over right units, or right h units, up k units to here. Now here we have multiplication outside and inside the function. A f of x, it'll stretch, squeeze, or flip the graph vertically. If a is bigger than 1, then the stretch is vertical. So this is the graph of y equals f of x, and here's the graph of y equals twice f of x, twice as tall. If its a is between 0 and 1, then it's a vertical squeeze. Here's the graph of y equals a half f of x, it's half as tall. And if a is negative, then it flips up or down. This is the graph of y equals f of x, then here's the graph of y equals minus f of x flipped upside down. So if you have y equals af of x, that modulates the amplitude of the function. The AM as an amplitude modulation. That's how AM radio works. There's the tower emits a radio signal whose amplitude rises and falls and rises and falls in accordance with the sound wave that it's transmitting. The difficulty with AM radio is that where the amplitude is low, like here or here, then the signal can be compromised by electrical noise, lightning, electrical discharges, someone starting up their car or their lawnmower or what have you. That's why AM radio is reserved for signals that can take a little bit of static, like voice transmission. Now, here's y equals f of bx. Here we multiply inside the function rather than outside. So this will stretch, squeeze, or flip the graph horizontally. And as before, it has a reverse effect. Here, if b is bigger than 1, it's a squeeze rather than a stretch. Everything happens faster. So this is y equals f of x, and here's y f of 2x. It's just squeeze left for right. If b is between 0 and 1, it's a stretch. Everything happens slower. Here's y equals f of a half x, stretched out horizontally outwards. And if b is negative, it flips left to right. So if this is f of x, here's f of negative x, flip from here left to right. So f of bx, b modulates the frequency as in frequency modulation radio, FM radio. There, the radio tower emits a radio signal whose frequency is shorter or longer or shorter in accordance with the signal. Now, the thing about FM radio is that it doesn't have a low amplitude difference, so it's less vulnerable to electric noise. So therefore, FM radio was reserved for signals that require a high quality signal, such as music. Here we have what putting a negative does to a function. So this is the graph of y equals f of x. This is the graph of y equals negative f of x, flipped up or down. Here's the graph of f of negative x flipped left to right. And if you do both, negative f of negative x, then it flips left to right, then up for down, which has the effect of flip left to right, up for down, is the same as a 180 degree turn. So it's rotation around the origin. So for example, graph y, the square of x minus 3. Well, y equals x squared has this U-shaped graph. This minus 3 moves it to the right 3. So it's a U-shaped graph touching down at 3. Y equals a quarter x plus 4. Or 1 over x plus 4, excuse me. 1 over x has this hyperbolic graph. And this plus 4 moves it up 4. So it looks like this. So instead of being asymptotic to the line y equals 0, it's asymptotic to the line y equals 4. Here we have y equals, graph y equals negative of x minus 2, that cubed. Okay, first, y equals x cubed has this n-shaped graph, which is momentarily flat at the origin. Okay, so the negative x cubed flips up or down, so you have this falling n-shaped graph. Then this minus 2 moves it to the right 2, so you have this n-shaped graph, which touches down briefly at 2 and then continues further down. Here we have this z-shaped graph from negative 5, 0 to negative 2, 3 through 0, 0 to 2, negative 3 to 5, 0. Graph y equals f of negative x plus 3. Graph negative twice f of x plus 3. For a, first, f of negative x, we flip left to right like this. So instead of the G-shaped graph, you get an S-shaped graph. Then plus 3 raises it 3 units. So here's the graph. For B, first negative twice f of x is flipped up or down and then also stretched vertically. Then add 3, move it up 3, so you get this graph here. Okay. For this, let's stop this recording.